Blockchain is still in very early stages of its evolution. In order for this technology to reach its full potential, one of the most important challenges of the scalability needs to be addressed. Unless we are able to address the scalability issues, we have a long way to go before blockchains can be used in daily lives of 7 billion people. Why is scaling blockchain is such a hard problem, you might ask? We know that a blockchain is a time-linked distributed database. Each computer or node in the network must retain a copy of the ledger. This redundancy reduces the risk of corruption by any individual person or group inside the network. One trade-off with distributed systems is that since each computer must retain a copy of the database, which constrains the throughput of the system. Essentially, the system only works as fast as any single computer can process transactions. Most current blockchains were designed with scaling as an afterthought. Instead, blockchains like Bitcoin choose to prioritize features like security, decentralization, immutability, and censorship resistance. There are two main approaches for scaling blockchains. Improve the base layer blockchain, which is the on-chain scaling, or a layered approach with multiple protocols working together, which is the off-chain scaling. Let's look at both these options, examine the pros and cons of other related details. One aspect of off-chain and on-chain would be the data storage. This can be implemented as storing data in a private or publicly accessible services. Off-chain does not necessarily mean not on the blockchain. It basically means that it's not on a publicly accessible service. Just like any organization would not store their data on a publicly accessible database or directory, off-chain storage means that the data is not publicly accessible. If you apply these concepts to a traditional cloud service, it would be very similar to a public cloud versus private cloud. So, what are the on-chain transactions? These transactions are valid when transacted on the public ledger. They involve many participants verifying transactions, and the validation signatures from all participants need to be an exact match in order for the transaction to be considered valid. While the specifics of each transaction are published on the public blockchain for inspection so that they cannot be changed or revealed back. It may take more time compared to that of off-chain transactions. Also, there is very likely potential that the transaction cost could be expensive, because of which members may prefer the off-chain system. And what are the off-chain transactions? Off-chain transactions deal with values that are outside the blockchain and can be completed using a number of methods. Both parties must agree about the transfer, then another party comes in to validate the transaction. Any sort of transaction which is conducted by off-chain is quite fast and instantaneous without the higher fees of on-chain transactions. So, what are the advantages to off-chain transactions over on-chain transactions? There are several reasons why an off-chain storage mechanism may be one of the main considerations when architecting a blockchain solution. One common use of off-chain storage can be to support a cache of the most recent values of the state of on-chain data. Off-chain data storage systems can be easily used as a backup to contain the large amount of artifact application data. This is done by using the point-in-time artifact data which is stored off-chain. Another important factor of the off-chain system is that it can easily store any type of real sensitive data. As on-chain data is non-negotiable in terms of modification, this sort of problem does not arise with the off-chain data management system. A few of the obvious advantages are, it's faster. The transactions are recorded instantly without having to wait for the network confirmations. It's cheaper too. Transactions done off-chain are usually free. It's more private. These transfers are not visible on the public blockchain. Consider a transaction like a cross-border crypto asset transfer or a trade. An on-chain transaction is best suited as it brings complete transparency and auditability to the transaction itself. Let's expand on that a bit further. Let's assume Alice sends 10 bitcoins to Bob. Now, if this is an on-chain transaction, it's public knowledge and proof that Alice did send 10 bitcoins to Bob, and the reverse proof that Bob did receive 10 bitcoins also on the public domain. Now let's correlate that the exact same transaction to an off-chain transaction with a hash or a proof of that transaction pegged to a public blockchain. In this scenario, it's proved that Alice sent something to Bob and Bob received something is a public knowledge. However, the exact number of bitcoins transferred stays rooted in the sidechain and is not public knowledge. On-chain transactions are best for cryptocurrency transfers, whereas off-chain are non-crypto related. A good example of this is the use of decentralized identifiers or DIDs. A DID could be public domain knowledge and could be pegged to a public blockchain like Bitcoin. However, the personally identifiable information or PII associated with the DID remains pegged on a sidechain that only you have access to, and you could choose whom to share the PII data with, when, where and how, which really puts you in complete control of your identity information on the blockchain. Let us look at some other aspects of scaling that can be brought in using on-chain and off-chain techniques. On-chain scaling methods include improving the throughput of the base layer of the network. For existing chains, this means improving latency in the peer-to-peer layer, reducing the size of transactions and messages, etc. One example of on-chain scaling success is Bitcoin's implementation of segregated witness, also known as SegWit, as a soft fork. SegWit reduced the size of Bitcoin transactions that ultimately get stored in the blockchain forever. Unfortunately, making scalability improvements to existing blockchain-based layers are unlikely to achieve the level of scalability needed to reach a mainstream global audience. Sticking to Bitcoin example, even if Bitcoin improves the base layer scalability by say 10 times, it still wouldn't satisfy the needs of a global economy's method of payment. This is why Bitcoin is focused on off-chain scaling. Another way to radically improve on-chain scaling is to create a new network with new consensus mechanism that prioritizes scaling instead of other potentially desirable features. This means finding an alternative to existing consensus mechanisms such as proof of work used in Bitcoin, proof of stake used in Ethereum 2.0, or delegated proof of stake used in EOS. Note that the major difference between Ethereum 1.0 and 2.0 is the use of POW and POS respectively. Off-chain scaling means creating alternative protocols that live on top of the blockchain. These protocols unlock new functionality for the digital assets with different design trade-offs. For reference, our current internet is built in layers. Important to visit a law known as Gall's law, which states a complex system that works is invariably found to have evolved from a simple system that worked. A complex system designed from scratch never works and cannot be patched up to make it work. Bitcoin's Lightning Network is the most known off-chain scaling solution in the market. The Lightning Network is a clever solution using payment channels to defer settlement to the base layer. It provides a trustless way to process Bitcoin transactions fast and cheap, but doesn't quite provide the same security assurance as on-chain transactions. The Lightning Network is new and there are still many challenges ahead. One major issue currently with Lightning Network is that it requires a large amount of liquidity locked up in the network. Another issue might be the increased privacy of stakeholders vis-a-vis governments. Anonymity from user perspective is good and also one of the basic premise of blockchain, but authorities and governments may not like it. I will not be wrong in making a statement. Now that blockchain has proven its feature like immutability, anonymity, transparency, decentralization, etc., the major work or research that is going on is on performance, throughput, and scaling issues.